All right, today we're going to be talking about lesson 2, which is classifying triangles. It comes out of the same lesson that the Pythagorean theorem came out of on Thursday. So we're in section 8.1, but this is the second part of that section, and it's called classifying triangles. So our objective today is to take the side lengths of a triangle and classify them by their angle measure. And to classify by angle measure would be to call it an acute, a right, or an obtuse triangle. So we want to use a theorem that is the converse of the Pythagorean theorem. It says, you know that if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the square of the length of the legs. We did that last Thursday. But now the converse of that is also true. And you understand if you want to write the converse, then you just switch the hypothesis with the conclusion. So in the Pythagorean theorem, it says, if a triangle is a right triangle, so that part should slide to the end of the new converse. And so this is what Theorem 8.2 says, and it's called the converse of the Pythagorean theorem. If the square of the length of the longest side, they are now calling this the longest side because they don't know for sure that this is a right triangle. So if you take the longest side and you square it, and it is equal to the sum of this side squared and the other side squared, or equal to the sum of the squares of the lengths of the two sides, then the triangle is a right triangle. So what that means is I would take my longest side and square it, take each of the other two sides and square them, and if I get an equal sign right here, I can tell you for certain that that is a right triangle. Now, I don't like working with A, B, and C. I like putting it in words, just like the theorem stated it. So I think of it this way. If the longest side is squared, I square the short side, I square the middle length side, and all of that is equal, then I know that I'm going to call my triangle a right triangle. This is what it looks like mathematically, but sometimes I think it's easier for us to say it in words like this. All right. Now, we have a triangle here, but I don't know if it's right. And from the drawing's a little bit distorted, but remember when we use drawings, we use them just to represent. They don't have to be drawn to scale. So it says, are they right triangles? So it says we're going to use the converse of the Pythagorean theorem to determine whether they are right triangles or not. Now on your notes, you have space to do the arithmetic that we're fixing to do on the slides. So make sure you do this work in your slides. The work from the slides onto your paper. All right, so the first question, it says, let C be the longest side. Now, you may not know 7, 8, and the square root of 13. The square root of 113 is going to be something more than 10. I don't know what it is, but I know the square root of 100 would be 10, and this number is bigger than that. So the square root of 113 is the largest or the longest of the sides. So that's the side that goes on the left side and gets squared. Then the 7 is the short side, 8 is the middle length side. Now, I don't know if you understand this or not, but do you see how there's parentheses around here? When you square a square root, you just come up with the radical or the number underneath it. So this is going to be 113. When you square 7, you get 49. When you square 8, you get 64. Now this is my question in here. If they come out to be equal, I can tell you that that's going to be a right triangle. And when I add the right side up, it equals the left side. So I can tell you that this triangle is a right triangle. Let me point out again, when you punch this into your calculator, put parentheses, square root of 113, close your parentheses, and square it. Let's try the next triangle. This one has 4 square roots of 95, 36, and 15. Again, the square root of 95 is almost 10, and 10 times 4 is 40. Or you can punch that into your calculator and see how much would 4 times the square root of 95 equal, and see how much that would be. And then you can make certain like that. So when I punched it into my calculator, I got, I got that it came out to be 38.9. See if I can get it up there where you can see it. 4 times the square root of 95 is 38.98. So that's the biggest side. So on the left side, I'm going to put my biggest number and square it. See how all of that is inside parentheses? My shorter side is 15, and then my other length is 36. I always identify my longest and my shortest, and then I have a leftover length. When you square this side, it comes out to be 16 times 95, and you don't have to do it like that. You can just punch it into your calculator, and it's going to give you 1,520. When you multiply these out, you're going to get 1,521. They are not off by much, but they are not equal. So you would have to say that this triangle is not a right triangle. Now, if we just stopped with the converse of the Pythagorean theorem, we would think that all we could do is tell you, yes, you have a right triangle, or no, you don't. The converse of the Pythagorean theorem allows us to determine if, yes, we have a right triangle, or no, we don't have a right triangle. But I'm going to talk about 2 other theorems, and when you use these theorems, you can go a step beyond and tell me that, yes, it's obtuse or it is acute. So I have a way of determining if they're right, and now we're going to talk about ways to determine if they are obtuse or acute. This theorem, called the obtuse triangle theorem, starts out with the very same hypothesis. If the square of the length of the longest side, we don't call this the hypotenuse, it's the longest side. Here's the one difference in the theorem. A while ago in the converse it said is equal to. This says is greater than the sum of the squares of the lengths of the other 2 sides. Then the triangle is obtuse. This theorem looks exactly the same as the converse of the Pythagorean theorem, except for that symbol right there. Greater than means it's an obtuse, and that makes sense to me. Greater than 90 was obtuse. Greater than what would make it a right triangle will make it an obtuse triangle. Or I like the words. If the longest side squared greater than the short side squared plus the middle side squared, then I'm going to call that an obtuse triangle. If that symbol right there is greater than, my triangle is obtuse. Now you can just imagine what the theorem 8.4, the acute triangle theorem, would look like. It's going to start out with the very same hypothesis. If the square of the length of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other 2 sides, then the triangle is acute. Here was the change in words. Is less than. That's the only difference in this theorem and the previous one. So here, if I get a less than sign, I'm going to call this triangle or classify this triangle as acute. Or in words, very same thing we've been doing. If the longest side squared is less than the sum of these other 2 sides squared, then I'm going to call that an acute triangle. So basically, we can think about how to use these three triangles at once. Three theorems at once. They all start out with the same hypothesis, and I wrote that on your paper. They all start out with the same hypothesis. If the longest side squared, compare it to the square of the other two sides. So what is important is what I would put in place of this question mark. I'm asking what would be the relationship between the left side and the right side. And this is strictly arithmetic here. If I would say that they are equal, if I do the arithmetic and they are equal, I have to classify that as a right triangle. If I do the arithmetic and I use a greater than right is obtuse. If I do the arithmetic and it is acute, less than right means the angle or the triangle would be acute. Now this is the important thing, is that you have to line up your numbers like I have here. The longest side has to be isolated on the left by itself. The sum of the squares of the other two is on the right. If you don't remember to line it up like this, then this chart I have goes out the window. It doesn't work anymore. But as long as you're lining them up according to the hypothesis of these theorems, then you're going to get the correct answer. So it says we're going to be doing some classifying. Now here's what happens in the next slides. I don't give you a picture. In the first two I gave you a picture, so I gave you the impression that yes, a triangle had been formed. But I need you to decide whether the set of numbers can represent the side lengths of a triangle. If they can, I need you to classify the triangle as right, acute, or obtuse. Now there's two parts to this. The first thing we need to do is use the triangle inequality to confirm that each set of numbers will form a triangle. And that's something we learned back in chapter 5. And we'll talk about that in just a minute. And then if they do form a triangle, then we would need to compare the squares and classify the triangle as either right, acute, or obtuse. All right, so let's look at the examples. I have 4 examples, A, B, C, D, and we're going to talk about each one of them individually. Now here, just because I write down 3 numbers, 3 side lengths, does not mean we have a triangle. Do you remember that from chapter 5? We have to test and make sure the 2 short sides add up to be more than the third side. So here for problem 2A, my short sides were 38 and 77. That's more than 86, so I have a triangle. Now please notice I am not doing the classifying theorems here, because in the classifying theorems I would be squaring. I'm not doing any squaring. I'm making sure that the 2 big sides add up to be more than the third side so that I have a triangle. If you don't do this step, then you're starting to sometimes you're starting to classify and there's not even a triangle for you to classify. So there is a triangle. Remember, longest side, what's the relationship here? That's the important thing. Short side squared plus middle side squared. All right, so you got to make sure you know which ones are your long sides. So 86 is my long side. Put my other 2 sides on the left and square them. So I will get 7,396 on the left side, and I will get 7,373 on the right. Now, when you are doing your work on your reteaching assignment tonight, I do not have to see this middle step right here. I do not have to see that middle step. I need to see 86 squared, and what that is. I need to see what 38 squared plus 77 squared is. These 2 numbers, don't have to see this. You can just punch in this in your calculator and immediately give me 7,376. I need to see how you plugged it in. I need to see what your result was. And that's a greater than. Do you see how there's no question mark anymore? I put a greater than, so that means it is obtuse. The triangle is obtuse. All right, going on to the second problem. The numbers were 15, 17, and 32. I have a problem here. 15 plus 17 is equal to 32. In order to have a triangle, those two sides have to be more than 32. So since the sum of the lengths of the two shorter sides is equal to the third, no triangle is formed. I keep on going on to the next problem. All right, here I have 11.5, 36.5. I've got to test them. These two add up to be 38. 38 is more than the third longest side. So a triangle is formed. Here's my formula. Long, how does it compare to short squared plus middle length squared? My long side was 37.5, 11.5 squared, and 36.5 squared. Now remember, this is the step that I said I did not have to see. I do not necessarily have to see this step right here. I just put it in there so we would all be on the same page. I have to see where you plug them in. I have to see the result. You replace this question mark with a less than. I need to see what sign you're replacing it with. So you're replacing that with the less than. And since that's a less than, if you look back on your chart, less than turns into an acute triangle. And then our last problem was 3D. Now, if you go back and look, I did not put the numbers in the order necessarily that they would. When you're looking at D, I put the long side at the first. Here's the long side. These are my two short sides. So I'm trying to make sure that how do 9 and 13 relate to the problem. So 9 plus 13 is equal to 22. 22 is not greater than 23. So since the sum of the lengths of the two shorter sides is less than the length of the third side, no triangle is formed. All right, at this point, you need to watch the video that explains reteaching 8.1 on classifying triangles. I'm going to do a couple of problems off of that so that you'll have a good start on how to do today's assignment. All you have to do is submit the reteaching part of the assignment today. Thanks.